Hi folks, welcome back to Tech Days Online, day 3. My name's Martin Kern. We've got the last session of the day. I'm joined by Rob Miles. Hi Rob, how are you doing today?
Very well, thank you.
Very good. So Rob's got this interesting session called Web Development is Fun. I've been intrigued about this title all day long. I've been dying to understand what you're going to talk about, Rob.
It's coding is fun, really.
Coding is fun, okay.
Because you can do things for the web, and that's awesome.
Yeah.
And there's all kinds of bits and pieces you can do there. I take a much broader thing. I think that coding is just fun.
It is indeed fun,
in terms of what you can do. It's just the most creative thing you can do. Yeah. If I can play the violin, I can play the violin. If I can draw a picture, I can draw a picture. If I can code, I can make music, I can do graphics, I can make games, I can think of a new experience and then write a program to give people that experience. Awesome stuff.
It is indeed, yeah, I absolutely agree. I think it is a very creative thing to do. It's that moment when you've been working on a little problem and after a day or so you suddenly got that particular thing to work, that kind of yes moment.
And doodling with code is fun too. Just writing a piece of code just to see what it'll do. Yeah. I do some games work with the students, and just with the game it's awesome because if it goes wrong, that's interesting as well. So you get another kind of gameplay dynamic just because your code didn't do what you thought it would. Excellent. And I love that.
Yeah, that sounds excellent. So Rob, what are you going to take us through today then?
Well, a little bit about me, a bit about the importance of fun when learning how to code, some stuff about a thing called Snaps, which is a framework I've invented to teach programming, and then a move into the Internet of Things, a chip that could change your life.
Really? Wow,
yes, it'll make you £3 poorer at the very least. And then a bit about web serving robots and bits and pieces and the importance of cheese when making robots, and then a shameless book plug at the end. Excellent. And we all go home for tea.
Well, that sounds like a lot of fun. I particularly like the robots aspect there, and cheese as well. Who doesn't love cheese?
Oh, yes.
Okay, sounds really good. So about you then, Rob?
Well, basically, I've been learning to program since we had punch cards.
Right.
And that was 30 or 40 years ago, and you got 3 runs a day, and I still love doing it, and I'm still learning, which is interesting. I think C# is a wonderful first language. If you want to learn to program, I think C# is a great place to go. Python's hilarious. Everyone should know about Python because Python is just nuts. The Arduino is a fun device. I'll show one of those in a minute or two, as is the ESP8266, and the one that everyone's heard of, Raspberry Pi. That's a good device too. I blog at robmiles.com. Everyone should go there. I'm surprised you haven't already.
I may have been there.
What a man. Thank you so much. And I tweet at Rob Miles as well. And I'm a Windows MVP on the development side, which is quite cute too. So that's kind of what I do. Like I said, it's the most empowering thing you can do. But I do get worried when people say learning to program is easy and fun, because in my experience it wasn't. It was really hard. It's like people buy a guitar and sort of start booking Wembley out.
Yeah, they can make some noises with the guitar, but it's not necessarily music, is it?
Absolutely. It's one of these situations where you've got this urge to do stuff, but you can't get your head around how you're meant to make it happen. And that's the hard bit about programming. You can teach people what a language looks like and how to spell if, and all that kind of stuff really quickly. But the difficult thing is then when you give someone a problem and say, write a program to solve that. Because to do that, you have to know how the computer thinks. And it doesn't think like us. It can do simple things real quick, whereas we can do complex things fairly slowly. And that's the sort of horrible bit when you think you know how to program because you know how a for loop works, and then someone says, okay, sort 10 numbers. And you just,
I always think tackling a real world problem is the way to learn a new technology. That's what I always try and do.
It's absolutely right. If you're not trying to do something with it, then there's absolutely no point in having it at all. So you should, quite right, point yourself at something and try and do it. And if you think it's pretty impossible at the start, that's actually quite a good thing because it sort of gets you sort of really determined to try and beat this thing into the ground.
Fantastic. Okay, I definitely agree with that.
And I think from the point of view of doing stuff, 2 things really are important. One is having a proper structured program to go at, and the other is being able to make something which is properly and genuinely useful to the person, because that's also motivating. And again, in that respect, I think trying to write games is actually a good thing. Because with games, as I was saying before, if it goes wrong, that's still interesting. And you control the entire universe. You haven't got like a customer who must have this thing working at 5 o'clock on Friday because that's when they ship the product. You can just fiddle around with and doodle with code. And so that kind of thing I think is really important. So when I'm teaching people to program, try and give them frameworks in which they can experiment and build confidence and try and make stuff work.
Yeah.
And that's kind of where we're coming from. And after a while it gets to be fun.
Yeah.
Because you're doing things, and I think one of the reasons we're on this planet is to try and impress each other, heavens forbid, and being able to write programs is a good way to impress people as well, because you can knock out things. I don't know about you, but the experience of seeing somebody else use your code,
absolutely, yeah,
and actually find it useful.
Yeah, it's a very. I used to work on an e-commerce system, and then seeing the orders coming through that system on a daily basis was a really empowering thing, because you know that they've used your system to place the order, they've navigated around the website, they've added to cart, all that kind of stuff. All the code you've written has ended up in this order arriving to be fulfilled. So yeah, very, very empowering.
Many years ago I put some code in a laser marking machine, and I went down to the shop and had a big production line full of these things, and they all had my programs in. And I'm going, ooh, this is a bit worrying, Rob.
Well, I heard a good analogy the other day about code quality, and the analogy was, would you ever travel in a plane that was running your software? And the guy that I was with, a colleague of mine, Rob Fraser, actually used to work on aeroplane systems, and actually has travelled in a plane that's been running his software. So he was able to say yes. I probably on the other hand would say no in most cases for that, sadly. But
it depends how old I am when you ask the question.
Okay, fair enough.
About now, yeah, I'm okay for now. 20 years ago,
maybe not.
We shall see. But yeah, it's an interesting business, because we both know that getting something perfect is really, really, really hard to do.
Sure, yeah.
And getting something good enough is quite often what you're aiming for, if you're honest about it.
Yeah.
And so yes, there is that side of things is also very interesting to explore as well.
Okay.
And we try and get students thinking about that kind of stuff. Everything has a price, because they come in thinking everything must be perfect. And the answer is yes, you could make it perfect, but you might.
How long do you want to spend?
It might take a year to do that.
Yeah, sure.
And so off you go, and then you get sort of rules of business and whatnot come in as well. The thing that's interesting about learning how to program, though, is that we tend to do things in a sequential way, because that's kind of how we're programmed. We make a task, we do a job, we work on something, doing. And computers are fundamentally data processors. Stuff goes in, the program does something with it, stuff comes out. And that's in my experience, that's the best way to teach. Right. Because you have a sort of a nice sort of sausage machine type way of thinking about things. The problem comes in modern systems, because modern systems aren't like that. Right. When I was writing my punch card programs, it was great, because you had a punch card deck with the numbers on and a line printer printing the output. So it was a pretty strong mapping between what goes in and what comes out.
Sure.
These days, people are using network connections, mice, Wi-Fi, tilting the computer, using these fantastic rich environments that we get from things like Windows 10 and Windows apps and whatnot. But it's really hard to learn how to start coding that.
Sure.
It's really hard to sort of get it back to its sequential roots. And that's something which I think I'm trying to address with the code that I'm putting together to help people to learn how to program.
Right.
And so what I've done, and this is something which is a useful exercise for all developers anyway, is to try and put the sequential aspects of programming back into the way that you actually write your code.
Okay.
So that if you look at a Snaps program like the one I've got here, this is C#. It's using my little framework called Snaps, which is based around a thing called the Snaps engine. Now that's effectively a static class that provides a whole bunch of behaviors. If you think of it as like a console on steroids, then that's kind of a good way to regard it. And so Snaps provides things that you can do, and you can ask it to read a string. Now, in a console environment, that would just read a string from the thing. In this case, we pop up a dialog box, we ask the question, the user presses return, the program continues. I can then use standard C# to put the words "the Honourable Mr." in front of the name of my guest.
It's formal greeting. Right?
Oh, absolutely. In our house, it's that's, and wearing cummerbunds. It's all really important. So we can explore a bit of expression parsing and whatnot, and then we have a little method helper one called speak string, which is kind of useful too, because that actually makes the computer speak. Now this is where you can start impressing your mum, because now you can write a 3-line program that will talk to her. And that plays well at home.
I remember one of the very first programs I ever wrote was on an Amiga computer, and it did exactly that.
It's awesome.
You could get it to talk to you, and that blew my mind as a 15-year-old making that work. So.
And so at this point, it's starting to get interesting, and people are going, oh, I could make this say stuff, and you give it a string. And the wonderful thing about the Windows framework is that it's actually quite easy to do that as a programmer, because you just go and grab the library and build a thing and then whack stuff into it. For someone learning how to code, tricky. So I've wrapped all that into a behavior which is just called speak string, and you give it the string and then out comes the text. But it's entirely sequential. I mean, the issue with Windows is that if I want to read something from a text box on the screen, normally I'd be binding event handlers to the button that you press when you want to say enter, and I'd be going off and reading stuff from the component on the screen, and then I'd be getting my string of text. So it wouldn't be sequential. I'd actually be having to do some trickery to make that happen. What I'm trying to do with the snaps thing is actually bring sequential back home in a well-behaved way. And this leads to that's a good posh word, corollary. For people
You'll have
who
to explain what that means.
So it's not a heart attack, it's something else. It basically is a little side issue, which is that for real programmers, it's useful to know how to do these things in the Windows framework as well, because sometimes when you're writing code and you're binding your event handlers and you're trying to make sure things happen in the right order, what you really want to do is get back to your sequential roots and actually make a sequence of statements that get the thing in, do something with it, and ship the answer out. Even though that's a web request and that thing there is from a dialogue and this thing here is going off and doing a database query, you really want to have those things running in sequence. And one of the sad things about the later frameworks is because they've been written properly from the OS point of view, they're all asynchronous. So everything happens in a way that you have to then sort of deal with. So what I've been playing with is a couple of things which I would strongly advise people to take a good hard look at when they're writing code. A thing called task completion source, which just search for it. There's a couple of fantastic videos about this on Channel 9 that take you through how to use it and when it's useful. But basically it's a way in which you can make a behavior of your own awaitable. So you can actually wrap up all your behaviors to go off and catch the events, use those to trigger the set result of the completion source, and at that point, whatever's waiting on it will continue.
That's
and
handy,
so this is something which is knockout handy, and it's one of the fundamental basis of the actual snaps framework that I'm using, is it builds this little framework and then goes off and does the waiting to get it done. And so take a look at that, because it's a really, really useful technique, particularly if you want to sort of sequentialize things. And the other thing which I'll mention, which is the flip side, is that if you want to actually make your application pause until something happens, and what this lets you do is take awaitable things and wrap them into just a straight line method call that runs inside your program and doesn't need to be awaited or anything. And these allow you to set a flag which will allow your application to continue, and it makes it, again, behave in a synchronous way, and is usable by all the little snaps methods that I'm using. Use this technique so that we're not clogging up the system with busy waiting. We're just actually running the thing through in a nice, well-behaved way. And this is kind of two things to look at: auto-set event and task completion source. These are tremendously useful little tricks. And I can show you some simple snaps, because if I whiz across to Visual Studio, I'll show you my pizza picker.
A pizza picker.
That's the wrong program. That's my deliberate mistake for today, folks. What we've got here is the snaps framework, and what you do is you get a whole ton of example programs keyed to the text in this book I happen to have written. Have I mentioned the book? Oh, I will.
You mentioned it a little bit, but I feel there's more mentions.
There's some big league pluggery coming down the track.
That's fine.
Absolutely.
That's all good.
This is actually my pizza picking program, and it kind of shows you what I'm going for. I want a program that you can pass your phone or your tablet or your whatever around the room, and people can pick the pizzas they want. Just press the button to get pepperoni or cheese and tomato or chicken or vegetarian or whatever. Another button you can press to actually get the totals. So if you look here, what we've got is a method called select from 5 buttons, 5 button texts, a return string. So we call that method, and when it comes back, the user has pressed a button to pick one of those options. And then I could have used a switch, but in this case, this is quite early on before we've covered switches. So I have a bunch of conditionals that basically say if it's a cheese and tomato, we'll increment the counter for that. And so you can see that the code is actually really simple. But the thing that I really like about this is that it's actually useful. And if you are trying to elect the class president, or pick who's going to be milk monitor for the week, or you want to have a sort of that kind of thing, a secret ballot, you could use this code.
Absolutely,
and that allows you to talk to people about patterns, because you can say, okay, you've got this thing which you can use in context A.
Yeah.
Now we can start thinking about context B, C, D, and a whole bunch of other ones. I've no idea what you want to use it for.
Yeah.
And that's, again, it's a big chunk of programming. The fact that you can take a thing which works in one context and then start making really good use of it in others is kind of important too. So I then have this, so effectively, as far as the person consuming my solution is concerned, they just get a program that puts buttons up. But as far as someone writing the code is concerned, it's all sequential. If they press the reset button, it basically clears all the counters. If they press the results button, it shows you all the numbers on the screen, and then it goes around again. And so if we run it up and deploy it, that's not going to work at all, because for some reason it seems to want to use my ARM device. Oh, very good. What's that going to do? Let's see, nothing useful. Okay, I guess we'll cancel that.
Don't want to be installing emulators.
There were deployment errors, you reckon? I think we'll not continue on that. So that's my failed demo out of the way as well. So let's go in here and just tell it I don't want to use my ARM. It will run on anything. This is kind of interesting. This is the wonderful thing about universal apps, that basically they are.
They are.
I ran this on my phone. That's how come it's actually. So let's use our local machines. In fact, it's local and a machine.
So this is written as a Windows app at the moment?
It's pure universal app, and the library is decoupled from the actual code. Yes, I know all about that. It's because I copied it to a different folder. And so it's all pure. I mean, there's nothing naughty happening, which means you couldn't run it in the marketplace or the App Store, wherever you like. And so now I go to chapter 7, because all my examples are organized by chapter, and then I go and find that's not right. It's in chapter 6. It's pizza picker. The idea is that you can run all these things instantly from the code. And so now what happens is we're getting our pizzas picking, and I can hit cheese and tomato and pepperoni and chicken, and let's have another chicken because I like chicken.
I like chicken as well. So
and cheese and tomato. Hit show totals, and then up come the totals. And away we go again. Now that's a useful program. It's a sequential program, and it's a Windows program, which is quite cute. And so this is sort of the basis of how the framework works. Now, if you download this stuff after having bought the book, of course, then you'll find that the entire framework is open as well. So you can see how I've used the events and the task manipulation to get these behaviors. So feel free to do that, steal the code and be rude about it. I don't have a problem with that. But the idea is that we're teaching programming. I mean, the thing which I found most interesting too is that Windows 10 does voice response.
It does indeed.
So if you roll down a few more examples, there's actually a version of this program, pretty much the same thing, where you speak what pizzas you want.
You can talk to it. Excellent.
And so this is the love, and again, that works again across all the platforms, because that's how these things are fitted together. So it's kind of a cute thing to do. So that's the basis of the way that Snaps works. And the idea is that you can start off writing programs and end up with stuff that's actually quite useful. But you're staying in a fairly simple sort of sandbox. The way the book works is the first 3 chapters, first 3 parts are actually Snaps based. Then the final part we actually move over and we start looking at how the Snaps components are used as part of the XAML that describes what they are, and then we move into the proper framework and start writing real genuine apps, because by then people have enough of a context to understand how classes work and how we have objects on our screen that are managed in terms of the classes and going from there. So it's kind of cute, and I'm having fun with that. And you can write games. Who
doesn't love a game?
Well, this is the thing is that one of the best examples that I've found for teaching class hierarchies is a sprite hierarchy for a game, where you have simple background sprites that don't do anything, they just sit on the screen. Then you have aliens that move but don't do much else. And you have a player that you can steer with your keypad, and so on and so on.
So they're all inheriting from the base class.
Absolutely.
Their own
and that's kind of how it's a really good way, because it's fairly obvious that an alien which shoots at you or chases you is only slightly different from an alien that just moves left and right. And so by a careful bit of design, you can reuse the code, and then you get all the benefits of fixing a bug in the parent and fixing the same bug for all the kids, and that kind of thing. So I couldn't resist putting some games things in. I had a lot of fun with X and A when I was younger, and I want to try and keep that kind of ethos along. So what we have is basically a little game engine which lets you put things on the screen and drive them round. And It's actually, one of the things that impressed me was that this is all done as a universal app using the standard components, which I'm then sort of wrapping things in to make them into sprites.
Yeah.
So my sprite is basically just an image in a Windows page. But you can have 500 of them, and it still works.
Sure, yeah.
600, 1,000, but 500's enough.
Yeah.
And so you can get really quite nice gameplay, sprite-based type stuff. And it's just, there's nothing special, it's just ordinary Windows stuff.
Yeah.
And it plays, it's rather good. So this is the kind of standard, because I want people writing games, you're thinking in terms of your game engine. So what I have here is just basically a ball that falls across the screen.
Okay.
So I tell the engine, I want you to run in a window at 60 hertz. I want you to load my ball from an image resource, add that to the game, scale it according to the size of the screen, give it a speed of 1 pixel per frame tick, and then in my loop, I basically move the ball on the screen and then redraw. And in that, you can start explaining to people how a game works. Because when they go into anything else, Unity or Monogame or any of the other frameworks, they find the same mechanism at work.
Same basic pattern.
All over the place. And that's kind of like a valuable lesson. So what you can do now is, let's have a look at I was particularly pleased with the name Space Invaders in Space. I thought that's a great name for a game. So the whole of the final section of the Snaps demos, all the ones towards the end down here, these guys are all game-based. And if I go to complete game, we can sort of see what the game looks like running under Snaps. And this is just all the same. So I've got my there you go, press space. I like press space to play. That pleases me as well for some reason.
It's kind of old school, that, isn't it?
Oh, yes. And so now I can use the cursor, or I can touch the screen and I can move it that way. If I had a gamepad, I could use that as well. And I can also use the cursors on the keyboard to move it around. And I can shoot these guys. And you didn't see the guy that chases me, but I've got a purple alien who uses just basically let's start again and see if I can avoid him this time. Because one of the things I also want people to understand is that actually making, I shot him again. I'm too good at this. Let's kill myself 3 times. I have, yes. The physics that controls the chasey alien, who I'm getting quite good at killing. Oh, I did it again. Oh, anyway. I
saw him briefly.
You saw him, he made a brief guest appearance. Yes, I need to work on this is the thing about gameplay. It isn't a programming problem. It's a testing problem. It's a user involvement problem. And that's interesting too, because I can make some code which is awesome, but the game's rubbish. And yet I've seen some really ropey code in my years looking at what the students have been making. And sometimes the game's fantastic, but the code itself is, why haven't you used loops? Who cares? So I need to work on the gameplay side. But the thing is, you've got some really simple physics behaviors, and yet you can get some things like angry wasps chasing you and all kinds of stuff. And that's again where you try and find a whole bunch of your family, friends, and anybody you meet to test your games and play with them. And it's the same with any program. This is a really important. One of the things we try and do with our students at the university is, if they make something, it's really fun to say, okay, you built this customer data entry system. Now enter 5 customer records with it. And you watch them flounder and go, it's not. And then you have to go back and rework it. And that's just how real life is.
Absolutely. Usability testing is one of the key things you can do.
Absolutely.
Actually watching real users that are independent from the project that you're doing actually use the application and just observe quietly over their shoulder as they trying to muddle their way through using the thing, you'll reveal a lot of insight on your design.
It can be soul destroying. Why haven't they pressed that button?
But it can also be very useful.
Oh yes, it makes it better. All this stuff makes it better. And this is what we tell the students if you're entering a game jam. One of the pro tips is always have a machine if you have a team of 5 of you, take 6 machines or so, and then have one as like the build server and the current state of the game, and always have that running the game that you're making as a work in progress. Anybody that walks by, get them to have a go
and see what you can learn about it.
And then if they say that's great but that's rubbish, then factor that into your next iteration, and always have something working that you can get the players to hit against.
Yeah.
Don't have great ideas and then think, I'll put those in when we build it, because trust me, you never will.
Yeah.
Because adding ideas to a project sends you backwards.
Yeah.
It's one of the developer stock faults. We tend to like to try and add things to impress people a bit more.
Yeah.
Then we have more work to do.
Yeah.
And that's a really
and more
bad,
things that can go wrong.
It's a bit like me saying, I'll wash your car, and I'll paint your house,
yeah.
and whatever,
yeah.
for free as well.
Yeah.
Other folk wouldn't do that,
yeah.
but programmers tend to do it because we like impressing.
And also we enjoy the craft of programming.
Oh yes,
well.
if it's the worst kind of problem, it's an interesting one.
Yeah.
Because you do those for free. It's, oh no, it's not interesting,
yeah.
and then you end up spending a lot more time on it than you should.
Yeah.
And off you go. But yeah, that's the way we are. I don't have a problem with that.
Yeah.
It's just interesting. So
okay.
right, so that's Snaps, and that's kind of how I think you should learn to program.
Okay.
And Snaps has an Internet of Things angle. I haven't brought my Pi with me, but there's a whole bunch of methods you can use to interact with pins on the Pi device, should you wish to do that too.
Yeah.
And that's really interesting.
Yeah.
One of the things I've experienced, if you want to impress somebody with a computer, you can make it do the most amazing graphics and have stuff with amazing response times and fantastic UI, and people will go, meh.
Yeah.
If you show them, you press a button and the light comes on.
Yeah, absolutely. There's something very strange about that physical
people
act of pressing something, a light coming on or a buzzer sounding or something like that.
Yeah, people go nuts.
Yeah.
They love it.
Yeah.
And it's this one makes a light flash. It basically it says make this into an output pin, turn it on, wait half a second, turn it off, wait half a second, and it will sit there flashing. But it's very easy to read a pin and make the button come on when you press it.
Yeah.
But yes, you're exactly right. There's something about wires and hardware and lights coming on.
I have a Vine video of me doing exactly that, pressing a button on a Pi and the light coming on, and then unpressing the button and the light going off, and that's been watched about 700 times now.
Yeah, it's so. It makes people, it's because you can see what's going on.
Yeah.
And if you're going back to learning how to code with your inputs and your outputs, it's really obvious what the input is. And it's really obvious what the output's supposed to do. And so it's an absolutely great way to learn. And this is the thing which I think, if there's a message I want you to take away from this at the end, everyone should rush out and buy one of these. It's called an ESP8266, and it's a Wi-Fi enabled processor, which can be a web server. Right. It can also do access point, or both. So you can basically have the internet in your pocket, and you can also connect it to physical devices, and it'll also run MDNS, so you can discover it on the local area network as well.
Okay.
You can use it to create any kind of internet-enabled appliance that you like, and it will talk to Azure via MQTT over secure sockets, which is what Azure needs, or you can use it and talk to it as a RESTful device.
Right. Okay.
That's that. It's about £3.
Really? Wow. Okay. So that thing about being £3 worse off, I can understand why now.
Absolutely. It's because if you have any kind of situation where at home or whatever that you think it might be fun to make an internet something, then this is an absolutely perfect way to do it. This is how I like to see it packaged. This is if you've heard of a thing called the Arduino, which is an awesome device. Until this thing came along, the Arduino was my favorite embedded platform, because that you can pick up for about £3, and you can use that to control devices, and it's really as a low layer. So you've got your Pi in the middle doing your integration, and you've got your Arduinos down at the front line talking to the hardware and doing the interesting stuff. And that's a really good way to architect. And your Pi runs Windows 10 and talks out to these guys, blah, 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 all runs nicely. This guy takes that and runs with it in that it provides the Wi-Fi connectivity experience as well. It's a little bit less well endowed in terms of pins for connectivity, but it means that you can write C++ programs using Visual Studio, deploy them into this thing, and within 10 minutes you can have a web server up on this, which you can browse from your phone. And when you hit load on your browser, a method fires in there that runs whatever code you put into it. So now you can, web-based control of stuff is just such a doddle. It's just so easy to do. And when you've got that kind of thing, the next thing that you want to do, I would suggest, is get yourself building some robots.
Everyone loves a robot.
And so what I'm doing is, there's another side project. I've got this dream, which is that in Hull, I'm involved with a group called the C4DI, which is it's an incubator for businesses and whatnot. We have a really nice new building down in the fruit market in Hull.
Okay.
And outside round the back, they have this awesome open air auditorium,
right.
which is it looks across the river at the deep, which is behind it, and it's fantastic. And I want to get 100 robots wandering around in there,
right.
just to see what they do.
Yeah.
And next year is Hull City of Culture 2017.
Okay.
And so as part of that, I want to see what, from an artistic point of view, you can get if you take 100 robots with lights on the top and set them off wandering around.
Yeah.
And if they're all networked, that's nice.
Yeah.
If they're all hanging off a server which is using a camera to track where they are and tell them where they are in the area, so each robot's got positional awareness, that's nice too. And if they've got enough sensors to react sensibly to the environment around them, that's kind of cute.
Yeah.
So I've come up with this thing called the Hull Pixel Bot.
Okay.
And it's basically a robot. One of the things I want to do that I haven't quite done yet is I want to link the Snaps framework to it. Okay. So you can start writing your little Snap sequential programs and putting them to use to control the robot.
Yeah.
And again, because it's so easy to interface to this darn thing, that's going to be quite an easy thing to do.
Yeah.
So the root of the game is piece head reaching down. This is my little robot.
Okay.
And what we have here is an Arduino, which is this guy here, but it could be one of my wireless ones. This is the first generation test platform. Underneath we have a bunch of batteries there, and then on top we have a nice big coloured pixel.
Okay.
And the pixel actually came from some wedding lights that I did. This is 2 years ago my daughter got married, and there's a wedding reception. And we were talking about what to put on the tables during the reception. Yeah. And my daughter said, I just want some fairly simple lights, you see. Okay. So I said, okay, I think we can do better than that. Yeah. So we ended up with 8 tables with rings of lights, all controlled from Windows Phone. So you could take the colour of the lights and all kinds of awesome things like that. And I've taken the same code and put it into my lights so they kind of flicker. And what my little robot will do is he will just wander around. And if he sees something, he'll turn. And if he doesn't see something, he'll keep going.
So I can see him reacting there.
And he reacts to my hand. If I take my hand away, he'll head gamely off towards the edge. Yeah. Although, if there's any, it tends to get the sensor is not a particularly great sensor, if I'm honest.
Would he wander off the edge if you let him?
Oh yes, he would do. Okay. He's extremely stupid. Okay. But the great thing about this robot is that once you've got your 3D printed parts, it costs you £10 to get the electrical bits.
Right.
Because what you find is that the Arduino you can pick up for £3 or £4. The motors are £1.60 each. Yeah. This sensor here, it's not great, but it is also about 70 pence. Yeah. Okay. So it's doesn't have to be that great. The switch will cost you about 50p, and the battery box is about £1 or so as well. Yeah. So you really can actually build one of these guys for around £10–12, depending on how many lights you want in here. Sure. The more LED you want in there, the more expensive it gets. Yeah. But the idea here is that it goes right back to what you were saying at the start. If you want to get into something, you have to start with an aim. You have to have a project. Absolutely, you have to have something to build. Yeah. Because just learning how this technology works is not going to do you any favours at all. What you really have to do is have some kind of trajectory, something you want to make. Yeah. So the idea here is that you can take your little robot and you can program him to do things. And you can do all that in Visual Studio. Yeah. And this is completely awesome. If I drop down to the code that controls my Pixel Bot, and I drift down here. This is C++, right, which is not a million miles away from C#. Okay. And this is the code that actually does all the robot control. It's a little bit more complicated than the Snap stuff because I'm doing fairly tight things, but it's great because the device you're going for has hardly any memory and a fairly slow processor by modern standards. And if it goes wrong, your program will just go. There's no beautiful single-stepping debugging, little bit, but not a lot. Yeah. So you have to put in all your own code coverage statements and printing. Sure. But it's a really fantastic challenge for a proper programmer. Okay. And it's also a great place if you just think in terms of making the robot move and turn. It's a good way to learn how to start coding as well, which is kind of interesting. So I'm writing Visual Studio, I'm writing C#. If I hit deploy, what happens now is very similar to what happens if you deploy to your phone, in that you plug the thing in via USB, the program goes out of the USB, goes into the device, sits in there and controls it. Okay. And so another thing to look for, if you're thinking in terms of things to actually directions to take your programming thing. Visual Micro for Visual Studio, it's a free download. And once you've got that, you're actually now in a position to actually write code for any of the Arduino platforms.
Okay.
And you can take all the skills that you've got and place them in a completely new field. And there's no operating system. It's just your code is running right on top of the metal.
Yeah.
So anything you want beyond the usual stuff, you have to make yourself. Although things like web servers and access point connection and whatnot, you can do quite easily using libraries that are already there. And if you use the WeMOS board, this guy here, this is one that I recommend. This guy, there's libraries for it, and you can even, although I haven't tried it, I must try this, you can deploy over the air.
Right.
So if I have a new version of my software, I can push that out remotely over Wi-Fi, which will, in the context of my 500, that's a bit ambitious, my 100 roaming robots, would actually be a very, very interesting thing to try and do.
Yeah, to make an update whilst they're all running.
So we can give them new behaviours and see what they do. I mean, the robots get more interesting when you look. This guy is like that guy, but he's got a bigger head. If you see, he's sort of got a little. And what we have here is an Arduino who's doing the actual motion, and an ESP device on top that does the radio, because it turns out that that's not a bad way to factor these things. And in terms of the cost, it's as cheap these days to add a second processor as to add a connector. They cost around the same amount of money. And so this guy receives the web requests, and then he sends the commands down a serial port to this guy, who then receives them and then drives the robot. At the moment, all he does is just flicker pretty colours, because that's what he does when he's waiting for commands to come down from this chap to tell him what to do. I had it all working last night. Honest, I had this is one of the things I'm most proud of. This was my desk setup last night, and on here I've got 3 copies of Visual Studio running at the same time.
Right.
One's talking to the Arduino, which is the motor controller. One's talking to the Wi-Fi adapter, which is the ESP, and then there's a third one talking to the universal application, which actually is doing the high-level control. And I thought that was just worth a photograph.
Yeah, absolutely.
So, and it was all running in parallel. It was all working beautifully, and I got the things working on my big-headed robot. And then I unplugged the USB and tried to use the batteries, and it all failed because my power supply needs sorting out. I have to sort out the voltage drop on the batteries is too much for the way I wired it to actually work properly. So I'm going to have to retreat and fiddle with that for a while. So I can't show you Wi-Fi controlled. I'm rather sad about. But the interesting thing about this as well, though, is that if you're playing with Windows Universal applications and you're looking at using embedded devices like this kind of thing on a local area network, there's a technology called MDNS, which is for subnets for local device discovery. It's the basis of Apple's Bonjour technology, and it's how Apple find things on their networks. It's been a bit hard to use on Windows up until now. There's now a Watcher framework for Windows 10 Universal apps. So what I was playing with over the weekend and managed to get to go was the fact that I can now run a Universal app on a Windows device and enumerate all the robots in the room like that. And so they just expose a service that could be a web, could be HTTP, or it could be a custom service for the robots. And then after that, you can then direct messages to those particular devices and find them. So if you're looking at device discovery on IoT, with Windows up until now, it's been quite a tricky business because you have to do dodgy net BIOS type things sometimes. But now it's there, it works. Just take a look at the Watcher stuff. There's an example on the big 30 megabyte download that you can get, a really big one with all the stuff in it. But take a look at robmiles.com in a while, because I'll be putting out how I've made it work. And that'll be very useful, because what you tend to end up doing when you're writing software for these guys is you hard code the IP address into the program when you build it. And that's okay. But it's not very flexible, it's not very portable, and it's not very scalable. So what you can do now is, if you had 20 of these in a room, you can actually enumerate them all and then direct messages to them. And these things can also discover themselves. So if you had 20 of these and you gave one robot the role of master, then that could then actually find it, they could agree with themselves, the one with the lowest serial number is the master, and then away you go. So take a look at that, because it's well worth exploring. And as I say, it's something which takes your, I mean, IoT, it's kind of cute. The thing that worries me about Internet of Things really is that it's so easy to do simple things badly. It's so easy to expose devices to in ways that mean they can be attacked in all kinds of unpleasant ways by people. That's why I like Windows 10 and Raspberry Pi so much, because Windows 10, whatever else it might be, is pretty darn solid. And it has a pretty solid upgrade mechanism, so you can deploy upgrades and things to your platforms very easily. Sure. If you write this kind of stuff, be quite careful how you do it, because if you don't want to have your house lights and whatnot visible for anybody to change on the internet, and so take a look at the MQTT.
Would it be able to hack into your house lights and flick them on and off at 3 in the morning, that kind of thing? Yeah. There's
a project on out there somewhere of a chap that's done his garage door with this technology, and I think it's a great idea, but it would worry me a lot unless you've got something quite secure in there. Because you don't want anyone to be able just to try a few IP addresses, hit yours, type in a command, and then the door opens. Sure. And so be mindful of that. That's one of the things that worries me a bit. But if it's just for fun, like this, then grand, go for it. If it's a little bit more advanced, then be mindful of the fact that you may be leaving a big hole for people to play with. So why am I telling all this? I think you should take a look at this stuff. You really, really should. And if you fancy building a pixel bot, if you want to get your kids into, and you happen to have a 3D printer, my experience with 3D printers is you get one, you play with it for a while, you print out a few cracker toys, you impress the wife, sort of, but she's still thinking, I could have bought that. And then you sort of run out of things to make. Right. But with this, there's a whole bunch of things you can make to build your own little robot. And if you find someone who has got a 3D printer, they like showing them off too. So just say, print this out for me, show it off, and they love doing that. So that's a good way to do that. And I'll give a quick shameless plug, if I may, to the book. Begin to Code with C#. It's in all good bookshops, and you can and a few dodgy ones as well. Who knows? You can find out where the example code is from Begin to Code with C#. If you search Amazon for it, you can find it on there as well. At the moment, the Kindle version is available for download, but the printed version will be starting to deliver, I think, end of this week or beginning of next. If you can program, then well, of course you should buy it, but you won't get. There's a few jokes in there, and you might get a bit of a giggle from those. But it's really for people with not a lot of programming experience. So
it's beginners, and if you've got an ambition to learn to code.
Absolutely, it doesn't teach you everything, but it teaches you enough to be dangerous and useful.
Okay, sounds like a good combination.
Which is go for one but not the other. Don't try and do. It's actually going out there. Begin C# is a website where you can get the code samples. They're all free to get hold of, and so please do that. In terms of things to do, I think you should buy one of these. I think you should go to AliExpress. Have you heard of AliExpress? No, it's basically the Chinese version of Amazon. Okay. And if you go there, whenever I go there, it usually costs me about £20. But here's the board which I was talking about. £2.97 free shipping from China. Wow. So that £3 I'm talking about, if you place the order, in about 2 weeks' time, a little package from all the way from China will arrive with one of these in, and you can start having some fun making your own connected appliances. So please think about getting one of those, because they are kind of fun. If you do get one, drift down to Visual Micro and add that to Visual Studio, so you can, because that is the best place in the universe to write code. Right. Absolutely, without a doubt. And if you fancy making a robot, take a look at hullpixelbot.com, buy my book, and then read my blog, which is robmiles.com. Okay. Sounds like a lot of stuff to get stuck into there. Oh yes. Yeah. Very good. So, well, thank you very much. That was a fascinating talk, and I like the fact that we got robots, IoT, C#, Visual Studio, Windows apps. I forgot cheese. You can put a plate on there and move cheese around with it. I have done that. Paper plate on there works a treat. So get them to act as little waiters for you. Of course. Cheesing it. Very good. Okay. Well, thank you, Rob. I think that brings us to the end of our day here at Tech Days. We've covered quite a lot. We've covered Office, SharePoint, Xamarin, machine learning, cognitive services, robots, and of course cheese as well at the end there. So thanks for watching all day. I hope it's been useful. The hashtag TechDays is still live if you want to ask any questions on there. But other than that, thank you very much.